Musk's $1.25 trillion merger. Is the world ready for Elon Musk's out-of-this-world IPO?
Good morning, or, well, good afternoon, depending on where you are catching us in the global market cycle. Today is Tuesday, February 3rd, 2026.
It is.
And if you have been anywhere near a screen, a trading desk, or frankly just a window looking out at the world this morning, you know that the ground has shifted beneath our feet.
Shifted might be the understatement of the year. I mean, this is seismic. The atmosphere on the street right now, it is absolutely electric.
I can imagine.
I haven't seen traders this caffeinated or this agitated since the crypto crash of 24, or maybe even the original iPhone announcement way back in the day.
It really does feel like one of those where were you when moments. We're talking about the CNBC moment of the decade. The rumor mill has been churning for months. Speculation has been rampant. But yesterday, the ink finally dried. The speculation is over.
It's official.
SpaceX and xAI have officially announced a merger.
The two titans of Musk's empire are becoming one single entity.
And the numbers. I mean, we have to start with the numbers because they are just eye-watering. We are looking at a combined valuation of $1.25 trillion.
A trillion with a T.
That is a 1, followed by a decimal, followed by a whole lot of market cap.
It's staggering. To put that into perspective for everyone listening, that valuation makes this new combined entity larger than the GDP of most G20 nations.
That's incredible.
We're breaking it down as SpaceX coming in at roughly a $1 trillion valuation on its own, and xAI, which is, effectively a software startup being valued at $250 billion.
$250 billion. For a company that, let's be honest, sells a chatbot and some API keys.
Well, that's exactly what we need to get into, because looking at the S1 equivalent filings that dropped late last night, if you think this is just a rocket company buying a chatbot, you are missing the forest for the trees.
It feels like that on the surface, though, doesn't it?
Yeah.
You have the hardware guys, SpaceX, and then you have the software guys, xAI. But you're saying the mission statement here is completely different.
Completely different. This isn't an acquisition. It's a consolidation. It is the consolidation of physical infrastructure, the rockets, the towers, the satellites, and digital intelligence. The whole goal of this deep dive today is to unpack these filings.
Right.
We need to look at the risks, the engineering realities, and the why behind this massive move before the planned IPO in June.
Because you don't just merge a $1 trillion rocket company with a $250 billion AI company for fun. There has to be a survival mechanism here somewhere.
It is entirely about survival. And it changes the economic landscape of not just the aerospace industry, but the entire compute industry.
So let's get into the weeds. We have the deal structure and financial outlook. Let's unpack this June alignment everyone is whispering about.
Right. So according to the internal memos and the breakdown we have from the syndicate desk at Bloomberg, the target IPO window is set for June 8th through June 28th, 2026.
That is a very specific, very tight window. Why June? Any particular reason?
It's about the fiscal quarters and the alignment of debt maturity. They're calling this merger the June alignment internally. It's the precursor to getting the books in order so they can go public as one unified front.
Okay.
And they aren't just looking to float a few shares. They are seeking a capital raise of $50 billion.
$50 billion
Right.
In a single public offering. That would shatter records, wouldn't it?
It would, by a lot. And they are targeting a post-money valuation of $1.5 trillion.
Okay, stop there for a second. $1.5 trillion. We were talking about a company that, until yesterday, was private. Is there actually demand for this? Or is this just Musk putting a big number on a whiteboard and hoping for the best?
The demand is real. And we have data on the secondary markets. This is where employees and early investors trade shares before the public market opens.
Right, the pre-IPO market.
Exactly. Shares are currently changing hands at roughly $527 per share. That implies the market is already pricing in a massive premium.
But why? That's what I struggle with. We have thought of SpaceX as the rocket company for 20 years. They launched the Falcon 9, they land the booster on the boat, everyone cheers. It's a great hardware business.
A fantastic hardware business.
But hardware businesses usually trade at low multiples. They don't trade like tech stocks. They don't get these kinds of valuations.
That is exactly where the narrative flips. If you look at the 2026 revenue projections in the filing, the entire story has changed. The report explicitly calls this a shift from being a launch provider to a global utility.
Global utility, like an electric company or a water company. That sounds Boring, but also incredibly valuable.
Exactly. Think of it like that. Look at the numbers. Total projected revenue for 2026 is $25.9 billion. That is up 57% year over year.
57%, that's hypergrowth.
It is. That's not a utilities growth rate. That's a tech company's.
Okay, but where is that money coming from? Is it from NASA? From government contracts?
No, and that's the key. Launch revenue, so sending astronauts to the ISS, launching spy satellites for the NRO, all the rocket stuff, is only $7.2 billion of that total.
That's smaller than I expected. Significantly smaller.
It is the minority share. Now look at the other line items, Starlink and data center revenue.
$18.7 billion.
Bingo. The rockets are not the product anymore. The rockets are the delivery truck. The product is the data. The money isn't in burning kerosene, it's in moving bits.
So they're effectively an ISP that owns its own construction crew, a vertically integrated internet provider.
An ISP and a data center provider, that's the key, and the subscriber numbers back it up. Starlink subscribers are projected to double from 9.2 million in 2025 to 18.4 million in 2026.
Doubling in a year. What's the catalyst for that?
The direct-to-cell service.
Right, getting service on your normal phone without needing to buy a dish. That's a huge market.
It's a game changer. But this brings us back to the merger. Why bring xAI into this? If SpaceX is already printing money on data with Starlink, why do they need an AI company? Why take on the baggage of xAI, which is, just burning cash on training runs?
I assumed it was just to have the smartest AI running on the satellites. Better routing, better service.
That's part of it, but the financial structure is more cynical and, frankly, more brilliant. The merger assessment document we have describes this as vertical integration as risk containment.
Risk containment. Okay, break that down for me.
Think about the two business models. SpaceX has high capital expenditure, or CAP, volatility. They are building physical things. They are bending steel, pouring concrete for launch towers in Texas, and dealing with weather delays.
Right.
That is expensive, it's lumpy, and Wall Street hates lumpy spending.
Right. It's hard to predict quarterly earnings when a hurricane can hit your launch pad and throw everything off for months.
Precisely. Now look at xAI. They have high compute costs. They are burning billions buying NVIDIA chips and paying for electricity to train the models. But once that model is trained, the software margins, selling the API, selling the subscription to X Premium, are massive.
Software is always a better business than hardware on paper.
Yeah.
The margins are incredible.
We are talking 70% gross margins. So here is the synergy. You use the high predictable software margins from xAI to subsidize the heavy, lumpy infrastructure costs of SpaceX. It smooths out the balance sheet.
I see. So when SpaceX has a bad quarter because a rocket exploded on the pad, xAI's recurring subscription revenue covers the whole.
Exactly. It makes the whole enterprise look much more stable to investors. And conversely, SpaceX's infrastructure creates a moat for xAI.
A moat, as in a competitive advantage.
A massive one. If you are OpenAI or Google, you have to pay someone else for your compute. You rent server time from Amazon or Microsoft, you are a tenant.
You're paying rent to a landlord.
SpaceX owns the satellites. They own the energy source in space. They own the launch vehicle. Nobody can undercut xAI on the cost of compute because xAI's landlord is its own sister company.
It's a closed loop. They control every single variable from the silicon all the way up to the solar panel in orbit.
It is about risk transfer. Merging allows the combined entity to withstand the valuation drag of being an aerospace company by injecting the high margins of a software company. It's a way to tell Wall Street, don't treat us like Boeing. Treat us like Google.
Which is a very smart play considering Boeing isn't exactly the darling of the market right now.
Not at all.
But this pivot isn't just financial. It is technological. And this is where I want to slow down and really look at what they're building. Because I saw the filing number for the new constellation, and I had to wipe my glasses. I thought it was a typo.
That's a big number.
SpaceX is filing for 1 million satellites.
1 million?
That is. I struggle to even visualize that. We have a few thousand up there now, and people say it's crowded. 1 million. But the sources say these aren't just the flat Starlink dishes we are used to. They are calling them orbital micro data centers.
And that's the pivot to orbital compute. This is the heart of the xAI integration. They're completely redefining what a satellite does.
Before, it was just a mirror, right? I send a signal up from the ground, it bounces off the satellite, and it comes down to you, a relay.
Correct. It was a dumb pipe, basically a fiber optic cable in the sky.
Yeah.
But moving data is a low-margin business. Processing data, that is where the power is.
And the money.
And the money. They want to turn the satellite network into a global brain. They want to process the AI inference, the actual thinking in space right overhead.
But why? I mean, we have data centers on Earth. We have massive server farms in Virginia and Oregon and Iceland. Why go through the incredible hassle and expense of putting servers on a rocket and shooting them into a vacuum?
Because of something the industry is calling the terrestrial power wall.
The power wall. It sounds like a sci-fi movie title.
It feels like one, but it's a very real problem. Earth-based data centers are hitting a crisis point. I was reading a report just last week about a county in Virginia that is effectively blocking new data center builds because they literally cannot run enough power lines to the site.
I've heard about this. The grid can't handle it.
The grid is at its limit, and the water usage. A medium-sized data center drinks millions of gallons of water a year just for cooling.
And local communities are pushing back because it drains the water table, right?
Exactly. We are running out of cheap power and clean water in the places where the fiber lines are. Now, let's look at the economics of space. What is the cost of solar energy in orbit?
Well, the sun shines 2047 if you're in the right orbit. There are no clouds, no night if you position it right, so it's free.
The energy cost is $0.00. And the cooling.
It's freezing up there, right?
It's a vacuum. Now, cooling in a vacuum is actually tricky because there is no air to blow over the fans, but you use what are called radiative heat sinks. You just radiate the heat away into the blackness of space.
Yeah.
The cost of that cooling, zero.
And water.
Zero water usage.
So the utility bill, which is the single biggest operational cost for a data center on Earth, is effectively eliminated. Just gone.
Completely wiped out. Now you have to pay the ticket price to get it there. The hardware is more expensive to build. The report says about 1.5 times the cost of a terrestrial server rack because it has to be ruggedized for launch and space.
Okay, so higher upfront cost.
Higher upfront, yes. But the comparative analysis source we have states that when you look at the 5-year total cost of ownership, it is roughly 60% cheaper per JFLOP in space than on Earth.
60% cheaper.
Yes. 60, because you aren't paying the electric company and the water company every single month for 5 years.
That is a complete game changer for AI economics. I mean, if you are training a model that costs $1 billion in electricity, and you can knock 60% off that bill.
That's the margin xAI is chasing. That is why they're merging. And then there's the latency argument. They are building a global laser mesh between these satellites. They are targeting less than 10 milliseconds of latency anywhere on Earth.
Which is faster than fiber in many cases because light travels faster in a vacuum than it does in glass.
Exactly. So you could run high-speed trading, real-time gaming, autonomous vehicle coordination, all processed from space, faster than you could from a data center on the ground.
But I want to visualize this orbital micro data center. When you say satellite, I think of something the size of a washing machine, maybe a fridge. For a big one?
Think bigger. Much, much bigger. The source documents describe these new V3 data center satellites. The main body, the bus they call it, is the size of a city bus.
A city bus, flying at 17,000 miles per hour.
Yes. And the wingspan. To run those high-end AI chips, you need a massive amount of power. When those solar arrays unfurl, the wingspan is 35 meters. That is 115 feet.
Wait, 115 feet? That is comparable to a Boeing 737?
It is. So imagine a commercial airliner, but made of solar panels and servers, flying in orbit every few miles over your head. That is the scale of infrastructure we are talking about, massing about 2,000 kilograms per unit, 2 tons.
That is absolutely massive, and frankly, a little terrifying if you think about looking up. But let's talk about the inside of that bus, because putting a server rack in space isn't as simple as buying a Dell server and strapping it to a rocket. Space is a nasty place.
It is incredibly hostile. You have thermal cycling from hot to cold, you have vacuum welding, and you have radiation. And the engineering feat document gives us a fascinating look at their silicon strategy.
They aren't just using off-the-shelf chips, are they?
Well, yes and no. They are using NVIDIA's custom Thor architecture, which is a beast of a chip, but they are also integrating xAI's proprietary Grok 1 inference chips.
There is that vertical integration again. Building their own silicon.
But the design philosophy is the interesting part. On Earth, for a data center, we prioritize raw clock speed. We want the fastest calculation possible, and we don't care how hot it gets because we just blast air conditioning at it.
Right. Power is no object, just speed.
In space, they're prioritizing performance per watt. They need low-voltage, high-throughput chips because even with those massive solar wings, power is a finite budget. You can't just plug into the grid if you need more juice.
And then there is the radiation. I remember reading about the South Atlantic anomaly, this spot over Brazil where radiation is just intense. Space is full of protons and cosmic rays that love to destroy electronics. How do they stop a $20,000 NVIDIA chip from getting fried instantly?
Two very clever ways. First, something they call space armor.
Sounds like a video game perk.
It does. They are using composite tiles from a company called Atomic 6. These tiles use high hydrogen polymers.
High hydrogen polymers. Okay, why hydrogen? I would have guessed lead.
That's the counterintuitive part. Think of a proton, the radiation, as a bowling ball. If you throw a bowling ball at a concrete wall, which is like lead or heavy metal, it shatters. It creates shrapnel. In radiation terms, that's called secondary radiation, which is even worse for the chips.
Okay.
But hydrogen atoms are like other bowling balls. They are about the same mass as a proton. So when the radiation hits the hydrogen polymer, it's like hitting billiard balls. It scatters the energy efficiently without creating all that dangerous shrapnel. It slows the radiation down gently.
That is fascinating. So plastic is actually better than lead for this.
In this specific case, yes, it's a much more elegant solution. But the armor isn't perfect. Some radiation will inevitably get through. And that is where the second strategy comes in. It's called triple modular redundancy, or TMR.
I saw this in the notes. This is the part that I found really clever and almost simple.
It is brilliant in its simplicity. Usually for space missions, NASA buys special radiation-hardened chips. These are old, slow chips that are built like tanks. They cost a fortune, and they are decades behind in performance.
Right. The rovers on Mars run on processors from like 1998.
Exactly. SpaceX says, we don't want 1998 chips, we want 2026 AI chips. But those chips are fragile, so they use 3 of them.
3 normal consumer-grade chips.
Yes. And they wire them together to perform the exact same calculations simultaneously.
Okay, walk me through that. How does that work in practice?
Let's say the satellite needs to calculate a trajectory adjustment. It sends the exact same math problem to chip A, chip B, and chip C all at the same time.
Okay.
Chip A runs the numbers and says the answer is 4. Chip B runs the numbers and says the answer is 4. But chip C just got hit by a cosmic ray that flipped a bit in its memory. Chip C runs the numbers and says the answer is 4,000.
So you have a rogue chip giving a bad answer.
The system looks at the results. It sees 2 votes for 4 and 1 vote for 4,000. It follows the majority. It accepts 4 as the truth. And then it sends a reset command to chip C to reboot it and scrub the error.
It's democracy for silicon.
Yep.
They vote out the bad result.
It is. It allows the system to be resilient without being perfect. They can use cheap, fast, cutting-edge chips and just accept that they will fail occasionally because the system is designed to catch them.
That is just smart engineering. But all of this technology, the polymers, the chips, the solar arrays, it relies on actually building the things. And this brings us to a huge, huge problem. Segment 4. The supply chain bottlenecks, or as the report calls it, the silver squeeze.
This is the risk factor that nobody on the financial news channels is talking about yet. We forget that the cloud is made of metal. Specifically, high-efficiency solar cells and high-end electronics require silver. It is the most conductive metal we have.
How much silver are we talking about here? Because silver is jewelry. It's a precious metal. It's expensive.
The statistic in the report is alarming. To build out this constellation of 1 million satellites with those massive 115-foot wings, the analysis suggests it could consume 15% of the annual global silver supply.
15%?
Yeah.
Just for one company.
Just for SpaceX. Imagine if Apple suddenly announced that the next iPhone needed 15% of the world's gold supply.
That would break the market. The price would go to the moon.
It creates a massive spike in global prices. It hurts the solar industry on Earth. It hurts electronics manufacturers. And it completely destroys SpaceX's margins. If the price of silver doubles, their cheap satellite isn't cheap anymore.
So what do? Do they just start buying up silver mines in Mexico and Peru?
They might have to, but the report mentions a technology pivot they're already working on to copper-nickel vapor deposition.
Okay, hold on. Vapor deposition. Break that down for us.
It is very high-tech. Instead of using solid silver wires or thick plating, they basically vaporize copper and nickel in a vacuum chamber and let it settle atom by atom onto the circuit boards. It creates ultra-thin, highly conductive layers using way less metal.
So they're trying to engineer their way out of the silver market entirely.
They have to. It shows how materials science dictates the pace of software deployment. You can have the best AI code in the world, but if you can't get the silver to power the chip that runs the code, you are stuck.
And it's not just silver, is it? The report mentions other constraints, the launch cadence itself.
The launch cadence is insane. To get 1 million satellites up there in a reasonable time frame, the report says they need a Starship launch every 4 to 6 hours.
Every 4 to 6 hours. That's not a space program. That's an airport. That's O'Hare.
It is. Imagine the logistics. Fueling, loading, launching, catching the booster, stacking the next one, 24 hours a day, 365 days a year. No breaks.
And there are other shortages too, right? The thrusters.
Argon gas. The Hall effect thrusters, which are these electric engines that use magnetic fields to shoot out plasma for propulsion. They usually use krypton or xenon.
Which are very rare, very expensive gases.
Exactly. So SpaceX switched to argon, which is cheap and plentiful, or it was. They're using so much of it that they are starting to drain the industrial supply. They're creating shortages.
So they're creating shortages in silver, argon, and presumably people. You can't run an airport with a handful of engineers.
Human capital is the breaking point. The report specifically mentions burnout risks at the Redmond and Bastrop facilities. You cannot run a 247 airport cadence with a standard 9-to-5 workforce. It's impossible.
You burn people out, they quit, you lose the institutional knowledge. It's a huge risk.
Which explains their manufacturing strategy. They are splitting hubs. Redmond, Washington remains the R&D brain, the skunk works, but they are moving mass production to Austin, Texas, co-locating it with the Giga Texas factory.
Tesla Terafab concept.
Correct. They want to treat satellites like cars, stamped out on an assembly line, not hand-built by artisans in lab coats.
Now, if you are putting 1 million satellites in the sky, you are going to ruffle some feathers. Actually, ruffle feathers is too mild. You are going to scare governments. And this takes us to the geopolitical side of things. Segment 5, orbital sovereignty.
This is a term we are going to be hearing a lot more of in 2026. Orbital sovereignty. Nations are waking up to the fact that low Earth orbit LO is a strategic domain. It is the new high ground.
Like the ocean or airspace.
Exactly. And just like with their airspace, they want to control what flies over their head.
And they don't necessarily want one American company controlled by one very unpredictable billionaire controlling the entire sky.
Exactly. China has been very, very vocal about this. On January 2nd, 2026, they issued a formal warning to the UN regarding what they called unchecked proliferation.
I remember that headline. It sounded like saber rattling at the time.
It was more than that. They cited safety concerns, but the real issue is data sovereignty. China views Starlink and xAI not as a public utility, but as a global eye for the U.S. military.
Which, to be fair, isn't a completely baseless fear. SpaceX has massive contracts with the Pentagon. The Starshield program is a real thing.
It is not baseless at all. If you have 1 million cameras and sensors looking down, you see everything. That is why China is pushing their own project, Thousand Sails, or Qianfan. They plan to launch 15,000 satellites to ensure they have their own network that doesn't touch American hardware.
So we're seeing the balkanization of space. The splinternet is moving to orbit. You'll have an American internet and a Chinese internet, and they won't talk to each other.
And don't forget Europe. The European Union passed the EU Space Act in June of 2025. They have strict sustainability standards now, and they're pushing their own Iris constellation. It's smaller, just 290 satellites, specifically as a privacy by design alternative.
So their sales pitch is, we won't let Musk see your data.
Essentially, they want to ensure European government data never touches foreign hardware. This leads to a huge regulatory risk for SpaceX. If these orbital sovereignty laws pass, countries could literally ban SpaceX from processing data while flying over their territory.
That would kill the utilization rates. Imagine a data center satellite flying over China or Europe and having to turn off its servers for 20 minutes.
It destroys the economics. If you can't use the satellite for half of its orbit, your cost per GFLOP effectively doubles.
It complicates that global utility narrative significantly. It's hard to be a global utility if half the globe bans you from operating.
Precisely. It becomes a patchwork utility.
But there is a risk that's bigger than politics, a physical risk. And this is the one that really keeps me up at night. Segment 6, the Kessler Syndrome.
The nightmare scenario.
For those who don't know, explain Kessler Syndrome.
Yeah.
Because it sounds like a medical condition, but it's actually a planetary catastrophe.
It's a chain reaction in orbit. Imagine a highway where all the cars are driving at 17,000 miles per hour. One car crashes. The debris, the shrapnel from that crash, flies out like shotgun pellets.
And those pellets hit other cars.
Those pellets hit other cars, causing them to crash, which creates more pellets, which hit more cars.
And because it's a vacuum, The debris doesn't slow down. It just keeps circling the Earth at incredible speeds.
Right. Kessler Syndrome is the tipping point where the density of objects becomes so high that a single collision triggers a self-sustaining cascade that shreds everything in orbit. It renders space unusable for centuries.
No GPS, no weather satellites, no Starlink. We'd be blinded.
And this isn't theoretical anymore, is it? We had an event just recently.
Yes.
On January 30th, 2026, just a few days ago, a defunct Russian satellite, LUCH number 40258, fragmented. It just broke apart.
Do we know why? Did it get hit by something?
The current theory is likely leftover fuel in the tanks expanding or an old battery exploding, but the cause doesn't matter as much as the result. It created a new cloud of dangerous debris.
That puts everyone on edge. So how does SpaceX plan to put 1 million satellites up there without turning LEO into a permanent junkyard? It feels incredibly reckless on the surface.
They have 3 main mitigation strategies, and they are relying heavily on physics and AI. The first is altitude. They are deliberately operating at ultra-low altitudes, below 500 kilometers, specifically between 340 and 480 kilometers.
Why does that help?
Atmospheric drag. At that altitude, there is still just enough atmosphere, just these tiny wisps of air, to act as a brake. It slows things down. If a satellite dies and loses power, the drag will pull it down and it will burn up in the atmosphere in months, not decades.
So the trash takes itself out.
Exactly. At 550 kilometers, where some other constellations operate, debris can stay up for decades or more. At 340 kilometers, it's gone in weeks. It is a self-cleaning orbit.
Okay, that's smart. But what are active satellites colliding with each other?
That is strategy number 2, AI collision avoidance. These satellites aren't just flying blind, they have autonomous thrusters. In 2025 alone, the Starlink network performed 300,000 collision avoidance maneuvers.
300,000. That is almost 1,000 a day.
It is. The logic is, if the system projects a probability of collision greater than 1 in 100,000, the satellite automatically moves. It dodges. It's like a self-driving car in 3-dimensional space.
But what happens when the satellite does come down at the end of its life? You said burn up, but does it really? We've seen pieces of spacecraft survive re-entry before.
That is strategy number 3, design for demisability.
Demisability. That's a very corporate way of saying easy to destroy.
It means designed to die gracefully. These new satellites are designed to be 100% demisable. They are made almost entirely of aluminum alloys and carbon fiber. They have systematically removed all titanium and stainless steel components from the external structure.
Because titanium has a really high melting point, it could survive.
Right. A chunk of titanium could survive re-entry and hit someone on the head. Aluminum vaporizes completely. The goal is that if they come down, they turn into a fine metallic dust high in the atmosphere before they ever reach the ground.
So they turn into glitter.
Ideally, yes, benign glitter. They are even talking about on-orbit recycling, with Starship in the future designing Starship to swallow old satellites, bring them inside, and harvest that silver and silicon we talked about earlier.
A garbage truck in space. I love it. Now let's bring it back to Earth for a moment, because there is a wild card in this deck that we haven't touched on yet. Segment 7. Optimus and the factory floor.
This connects right back to the labor shortages and the risk containment strategy. If you can't hire enough people, you have to build them.
And there was some breaking news on the car side of things, right? This is related.
Huge news. The company confirmed the discontinuation of the Tesla Model S and Model X lines by the second quarter of 2026.
The cars that started it all. The Model S is iconic.
Yeah.
And they are just cutting it.
Gone.
Yeah.
And the reason is very telling. They are repurposing the Fremont facility into a dedicated Optimus production factory.
The robot.
The robot. They are pivoting from being primarily a car company to being a physical AI company. The goal they've stated is 1 million robot units annually by the end of the decade.
But we have to be careful here, right? We have heard big promises about this robot for years. I saw the videos of it folding laundry. It was, well, it was slow. What is the reality of Optimus right now?
The reality, according to our sources, is that it is still very much in R&D. It is performing simple tasks, sorting parts, moving boxes from one bin to another. It is not building rocket engines yet. You aren't going to see a robot welding a Starship tomorrow.
So it's not replacing the engineers at Redmond just yet?
No. But the training method is what's interesting. They're solving the software problem by using humans. Workers at Giga Texas are currently wearing helmet-mounted camera rigs.
Like GoPros.
More advanced. They record exactly where the human looks and how their hands move, capturing the task from a first-person perspective. It provides what's called imitation learning data. Instead of putting someone in a motion capture suit with ping pong balls on it, they're just recording the job being done.
So the AI watches the video of a guy screwing in a bolt 10,000 times, and eventually it figures out how to move the servos to do the same thing.
Exactly. And it all links back to the terafab concept. Musk wants to integrate logic, memory, and packaging in-house to avoid the massive capex of external chip providers. Optimus is the labor force intended to solve that human capital bottleneck we mentioned earlier.
So the grand vision is robots build the satellites, rockets launch the satellites run the AI, and the AI makes the robots smarter.
It's the flywheel to end all flywheels,
Nah.
a completely self-contained industrial loop.
Okay, that is a lot. Let's try to synthesize all of this. Segment 8, the financial synthesis. We have a $1.25 trillion valuation. SpaceX is now more valuable than Boeing, Lockheed Martin, and Intel combined.
Let that sink in for a moment.
Yeah.
The new aerospace company is worth more than the entire old guard of aerospace and silicon manufacturing combined.
Is it justified? Let's look at the risks. Give me the bear case. Why does this all fail spectacularly?
The bear case is strong, and it revolves around a single concept: consumable infrastructure.
Break that down.
Satellites in a LEO, especially at those low, drag-heavy altitudes we mentioned, only last about 5 years. Their components degrade from radiation, they run out of fuel for maneuvering, and eventually they fall out of the sky.
Right. It's a planned obsolescence.
That means this isn't a one-time build like a bridge or a fiber optic cable. If you lay a fiber cable across the Atlantic, it sits on the ocean floor for 25 years generating cash. These satellites, you have to replace the entire million satellite network every 5 years.
It's a treadmill you never stop building.
It is a rolling CapEx nightmare. You are constantly spending billions and launching hundreds of thousands of satellites just to stay in the same place. It's like painting the Golden Gate Bridge. By the time you finish, you have to go back to the beginning and start over immediately.
And if silver prices spike or a launch pad explodes, that treadmill stops. But the satellites keep falling out of the sky. The network degrades.
Exactly.
Yeah.
And operationally, it's fragile. AI workloads hate faults. If radiation keeps flipping dits and forcing chip resets, can you really rely on it for mission-critical banking transactions or defense applications? The triple modular redundancy helps, but it's not foolproof.
Those are valid, very serious concerns. But what is the bull case? Why are investors lining up at $527 a share for a company with that much risk?
The bull case is the cross-subsidy and the monopoly. xAI inference scales with 70+% gross margins. It's almost pure profit. If the X platform, assuming Grok works and drives engagement, can hit mid-30% EBITDA margins, that cash creates a fire hose of liquidity.
Which funds the rockets and the constant satellite replacement.
Which funds the Mars ambition, that's the end game, and the defensibility. If they pull this off, they create a vertical monopoly unlike anything we've ever seen. Launch plus compute plus application.
Right.
Nobody else has that stack.
Right.
Google has the AI, but they don't have the rockets. Boeing has Boeing has issues, but nobody has the full stack.
It's the Apple of space. You control the hardware, the software, and the distribution network.
Precisely. The entire bet is this: can software margins outrun capital-intensive ambition? If the answer to that is yes, then $1.5 trillion might actually be cheap.
That is a wild thought. A $1.5 trillion bargain.
It is.
So, we have covered the deal, the tech, the geopolitics, the risks, and the money. What does this all mean for us, for the listener driving to work right now?
We are witnessing a fundamental shift from connecting the world to processing the world. This isn't just about faster internet for your cabin in the woods. It's about putting a supercomputer over every single square inch of the planet. It means intelligence AI becomes a utility like tap water, available everywhere, instantly.
And doing it with a business model that relies on constantly throwing things away and launching new ones.
Which brings me to a provocative thought to end on.
Go for it.
The report describes this orbital network as consumable infrastructure. We as a species, for our entire history, are used to building permanent things. Roads, bridges, data centers, things that last 50 years. We amortize the cost over generations.
Right. We build for the future. We build things to last.
What happens to the global economy when our primary computing infrastructure, the literal brain of the planet, has to be completely replaced every 5 years?
It becomes a subscription service. A permanent rent that humanity has to pay.
Is that sustainable? Or have we just created a permanent, inescapable, recurring cost for the human species? A tax on existence that we have to pay to the sky every 5 years, forever, just to keep the lights on.
That is something I'm going to be thinking about for a long, long time. It changes the entire definition of permanence.
It certainly does.
Well, that is all the time we have for today's deep dive. We want to thank you for listening to this breakdown of what might be the deal of the century.
Thanks for having me. It was a pleasure.
And remember, keep watching the skies.
And the ticker tape.
We'll see you next time.